Have you ever built a system that works but no one really understands it? Business rules are scattered everywhere, bugs keep coming back, and every new feature feels risky. Today I will show you how the professional teams avoid this chaos using the domain-driven design and how you can do it too. By the end of this video, you will know how to design a domain model of a football management system like a pro. If you are a developer who wants to build systems that are easier to understand, change, and scale, you are in the right place. Today, we are going to design a domain model of a real-world football club system using the domain-driven design, also known as DDD. We will build three real-world business areas such as club management, squad management, and also the transfer management. And you will learn how the concepts like aggregates, entities, value objects, and bounded contexts actually work. Not in a theory, but in a real system. Don't worry if these words sound scary. I will explain everything in plain English as we go. Let's start with the basic question, what is domain-driven design? Domain-driven design is an approach to the software design where the business domain is the center of everything. Instead of thinking about the databases and the framework, we focus on understanding how the business actually works. We ask questions like, what is the real world we are trying to model? The business rules become the heart of the system, and we write code to reflect the real world concepts and the processes. Domain-driven design is all about understanding the business first. For example, in a football league application, we have business rules such as clubs sign players, players have contracts, transfers only happen inside the transfer windows, and staff members work for clubs. Our job as a software developer is to turn that real-world domain into a clean, logical software model. Before we start writing code, the first step is to split the system into something called bounded context. Bounded context is a clearly defined business area with its own rules and the language. For example, we can divide a football league application into three business areas: club management, squad management, and the transfer management. In the club management, we deal with clubs, staff members, and their contracts. Similarly, the squad management is all about players. It deals with players, their positions, their statuses, and their contracts. And finally, we have transfer management that deals with transfers, transfer windows, and transfer statuses. Each bounded context is independent, they don't share the internal models, and they only communicate through contracts and events. This is why the domain-driven design scales so well. Aggregate root is the main entry point of a business concept. For example, in our domain model, the club, the player, and the transfer are the aggregates. These are the top-level objects available in these bounded contexts. And if you want to change something inside the bounded context, you must go through the aggregate root. You cannot directly modify the internal objects without going through the aggregate root. In the domain-driven model, the entities are the objects which are defined by their identities. If we have two entities in which all the properties are same but their identities are different, they will be considered as two different entities. In our domain model, the staff contract is an example of an entity. A value object is something that has no identity. They are called value objects because the only thing that matters are the values they have. If we have two value objects with similar values, they will be considered equal. In our domain model, the player stats and the transfer window are the examples of value objects. Before we start implementing our domain model, we need to create some shared classes and abstractions. These shared classes and abstractions are not the business features. They are the building blocks that the whole domain depend on. So let's create a folder in our project and name it shared kernel. The first interface I'm going to implement in this shared kernel folder is an entity. This interface is a marker interface and it doesn't declare any method. This interface will be used to mark the classes as entities. We already learned that in the domain-driven design, entity is something that has an identity, and it is something that can be tracked over time. The classes that will implement this interface will be treated as entities and they will represent something real in our business. Next, we need to create a new class in this shared kernel folder, and this class will be called base entity. This class will be an abstract class, and this class will be treated as the base entity for all the entities in my domain. This class will also implement the entity interface. For now, I'm leaving this class empty, but later on, we can add things like domain events, auditing, and tracking changes. By inheriting the base entity class, all the entries in our system will get those features for free. We also need to implement the value objects and aggregate routes in our domain model. So let's also create some market interfaces for these objects. I'm adding a new interface in my shared kernel folder, and this interface name will be iValueObject. All the value objects in my domain model will implement this interface. Similarly, I'm also creating another market interface, iAggregate I think you now have an idea that all the aggregate routes in my project will implement this iAggregate interface. Next thing I need to create in the shared kernel folder is a special type of exception called domain exception. This class is also going to be public, and this will inherit the .NET exception class. Inside this class, I'm going to implement few constructors. First constructor I need to implement will take a string message as a parameter. This constructor will pass the message parameter to the base class constructor. Next, I need a constructor with two parameters. The first parameter will be the same string message parameter, and the second parameter will be the inner exception. And this constructor will also pass these parameters to the base class constructor. Later on, we will throw this custom domain exception class from our domain model when something will violate the business rule. We now have all the base classes and interfaces we need for our domain model. We can now implement some shared classes and the value objects. And these shared objects will be used in many areas of our domain model. Let's first implement a shared value object, money. This value object is going to be public, and I will use the C# bracket to create this value object. It will have two properties, decimal amount and the currency. We already know that all the value objects in our project need to implement the iValueObject interface. This money value object is a clean way to model the money concept in our project, and it will be used later on to represent the player and the staff salaries. Instead of saying the staff salary is a decimal, it's always better to say that the staff salary is a money that has amount and a currency. In the real world, players and the staff members normally sign the contracts with the club, and these contracts always have some sort of time period associated with them. For example, if a player signs the contract with the club, that contract always has some sort of start date and end date. To represent the start date and end date, we can create a new value object in our shared kernel folder. And this value object is called date range. This value object will also implement the iValueObject interface. This value object will have two properties, start date and end date. We can also implement some basic date logic inside this date range value object. For example, if we want to check if the given date falls inside this date range, we can implement a simple method contains. This method will take a date time as a parameter, and it will simply check whether the given date falls inside this date range. Similarly, we can also implement another method that will check whether the two date ranges overlap with each other. This will be very useful later on when we will try to prevent some staff members to join two clubs at the same time. We already know that in our applications, we have business concepts such as player contracts and the staff contracts. And just like real-world applications, these staff contracts have some sort of life cycle. These contracts can be active or inactive, and they can also be suspended or terminated. So let's implement a new shared enum called contract status. This enum will contain a fixed set of values allowed for contract status. For example, contract status could be active, inactive, suspended, or terminated. These statuses clearly define the life cycle of the contract. This enum avoids the invalid values and makes it very easy for us to enforce the business rules. We already know that we need to implement 3 different bounded contexts. So let's create a feature folder for each one of these contexts. The first folder I'm going to create is a club. This folder will contain all the classes and objects related to club management context. Similarly, I'm also creating another folder for squad management context, and I can name this folder players. And finally, we need a folder transfers for transfer management context. Let's start modeling the domain of a club management context. Every club in the world have some staff members, and these staff members have different roles. So let's start with a simple enum staff role. This enum will represent all the staff roles available in a club. For example, in a football club, we can have roles such as coach, assistant coach, manager, physio, doctor, and analyst. Next, we need to implement an aggregate root called staff member. And for the staff member, we also need to implement a strongly typed ID called staff member ID. So let's first implement a strongly typed ID that will represent the staff member ID. Staff member ID is going to be public, and I will use some C# keyword here such as read-only, racket, and struct. These keywords will make sure that the staff member ID is a fast, clean, and immutable object, and it has the structured equality available by design. The staff member ID will only contain one property called value, and we already know that all the value objects in our project need to implement the iValue object. The strongly typed ID such as staff member ID makes our code safer because now we cannot accidentally pass the player ID or a club ID where the staff member ID is required. If you want to learn more about the strongly typed IDs, I will recommend you to watch my previous video. In our club management context, we also have an entity called staff contract. So let's create another strongly typed ID called staff contract ID. This strongly typed ID will be similar to the staff member ID we created earlier. It will also have one property value, and it will also implement the iValue object interface. We are now ready to implement the first main entity of our domain model. And this entity will be called staff contract. This entity will represent a real contract between the staff member and the club. I'm going to declare this class as public. We have already implemented a base class of all the entities in our domain model. And our staff contract entity also needs to inherit from the base entity class we created in the shared kernel. Let's now define some properties in the staff contract entity. The first property I'm going to define is an ID, and that ID will be a type of staff contract ID. I also need to make sure that the setter of this property is private. In the domain-driven design, we use private setters to make sure that no external code is allowed to change the values of these properties. These properties can only be changed from within the class using some sort of methods, and those methods can also enforce the business rules. Next property I'm going to create is a staff member ID, and this property will tell us which staff member is signing this contract. Next, we need a property to represent the time period of this contract, and we already know that we can represent a time period using a special value object date range we implemented earlier. So let's create a period property with the type date range. This property period will now specify the start date and the end date of the contract. Next, we need a property to specify the salary of the staff member. We can create a property using the money value object we created earlier. This property will tell us how much salary the staff member is paid in a particular currency. Finally, we need a property to represent the contract status, and we have already implemented an enum contract status for this purpose. Let's say you want to implement some feature in your application where you need to know whether the staff contract is active or not. And the business rule says that the staff contract will remain active if its status is active. And also it is still within the date range of contract period. Let's create a property isActive that will handle these two business rules. The first thing this property will check is whether the status is active or not. And the second rule I'm going to check here is whether today's date is still within the contract period. And this is where I can use the contains method we define in our date range value object. In this method, I'm going to pass today's date. We are now ready to create the first aggregate root of club management bounded context. And the first aggregate root I'm going to create is a staff member. So let's add a new class in this club folder, and I'm going to name it staff member. This class will also inherit from the base entity class we created in the shared kernel folder. But this class is not just a normal entity, it is also an aggregate root. So we need to implement the aggregate root interface on this class. First property I'm going to define is the ID. For the ID, we can use the strongly typed staff member ID we created earlier. Next property will be the full name property that will represent the full name of the staff member. Next property I'm going to define is the staff role, and here I can use the staff role enum I created earlier. And finally, we need a property that will represent all the contracts staff member will sign with different clubs. This property will be a list of staff contracts. You can see I have created all these properties with the private setters because I don't want these properties to be exposed outside the class. Next, we need to create some constructors in this aggregate root. The first constructor will be an empty constructor, and we need this constructor for the ORM such as entity framework. Second constructor will accept some parameters and it will initialize a staff member using those parameters. So let's create a constructor with some parameters. First parameter is going to be full name and the second parameter is going to be staff role. Inside this constructor, I can initialize these properties one by one. We also need to initialize the ID property of this staff member, and we can initialize this using the strongly typed staff member ID. And here inside the staff member ID, I can pass a new GUID. As a standard practice in domain-driven design, we need to make sure that both of these constructors are declared as private, because we don't want any external code to create different type of staff members randomly. External code should call a factory method to create a staff member objects. I'm going to create that factory method next. This method is going to be public and this method will return the staff member object. I can name it create. This method can accept the same parameter we already defined in the constructor. And inside this method, we can simply return a new staff member object. This factory method ensures that the staff member creation is always consistent and safe. And whenever we create a staff member object, we always set the full name and the role properties. In the real world, staff members sign contracts with different clubs. Let's say you have a business rule in your application that the staff member can only sign the contract with one club at a time. And the staff member cannot have multiple active contracts. I am now going to show you how you can apply these type of business rules in your domain model. I'm going to implement a new method called sign contract. This method will accept a new staff contract as a parameter. And the main job of this method is to add this new contract in the contracts collection. But before we add this contract, we need to ensure that the staff does not have any active contract. We can implement this business logic using a simple if condition. And inside this if condition, we simply need to check if there is any active contract available. Let's use the any operator here. And inside this any operator, we can specify the lambda expression and we can check the property is active. This condition will now tell us if there is any active contract available. And if there is some active contract available, we can throw a new domain exception with the message that staff member already has an active contract. We are now ready to create the most important aggregate root of this club domain model, and that's called club. But before we start implementing the club aggregate root, we need to create a strongly typed ID, club ID, to represent the identity of the club. So let's create a new class, club ID. This class will be similar to the strongly typed IDs we created earlier. It will be a read-only struct record. And internally, it will encapsulate the GUID value. We also need to make sure that it's implementing the iValue object. Once we have the strongly typed club ID implemented, we can now add a new class club in the club folder. This class will also inherit the base entity and it will also implement the aggregate root. This aggregate root will contain all the business rules related to club. The first thing I'm going to implement in this club aggregate root is the business rule constant. Let's say you have a business rule that maximum squad size of the club cannot exceed above 25. You can specify the squad size directly in your domain model using a constant. So let's create a constant integer and I'm going to name it maximum squad size. and the maximum squad size will be 25. Even though it's not used yet, but it shows that the domain rules such as squad size can live directly in your domain model instead of controllers or the database. Next, I'm going to define some properties of the club. The first property I'm going to define is the club ID. And this property will also have the private headers. Next property will be a name property, and this will represent the club name. Next, we need a property that will specify in which year the club is founded, and we can name it founded year. Next, we need a string property that will represent the website URL of the club. And finally, we need a property that will represent the staff members collection. We can name it staff members. And we can also initialize it with empty staff members collection. Just like the staff member aggregate, we also need to create two private constructors in this club aggregate. First private constructor is required for the entity framework. The second private constructor will accept some parameters and it will create club object using those parameters. The first parameter I'm going to pass is the name of the club. Second parameter could be founded year, and the third parameter could be a website URL. Inside the constructor, we first need to initialize the club ID using the new GUID ID. And after that, we can initialize the club properties one by one. We also need to create a public static factory method to make sure that the club objects can be created from outside. This method is going to return a club object, and I can once again name it create. This method will also accept the same parameter we already have in the club constructor. And inside this method, we can call the club constructor. We are now ready to implement some business logic in this club aggregate route, and I will show you how you can validate different type of business rules. The first method I'm going to create is add staff member, and this method will be used every time club will hire someone. Let's create a method called add staff member. This method will accept a parameter of staff member type, and the main job of this method is to add the staff member in the staff members collection. Let's say you have a business rule that club is only allowed to have one coach, and if someone will try to add another coach, the system should enforce this rule in the domain model, and it should not allow anyone to add two coaches. I will show you how you are going to implement this type of business rule in your domain model. The first thing you need to check is whether the staff member you are about to add is a coach or not. Because if this staff member is not a coach, you don't need to enforce anything. So here I'm going to check the role of this staff member. We already have a staff role enum, and we can use that enum here to check the role of this staff member. Now if this new staff member is coach, we need to check whether we already have a coach available or not. And we can easily check this in the existing staff members collection using the any method. Inside the any method, we can provide a lambda expression that will check the role of existing staff members. This condition is going to be true if we are adding a new coach and we already have a coach available in our staff members collection. And if this is the case, we will be throwing a new domain exception. And inside this domain exception, we can specify a message that the club can only have one coach. I think now you have some basic idea how to enforce the business rules using the domain-driven design. The aggregate rules such as this club entity are not just the containers of the data, but they are also the guardians of the business rules. The club aggregate controls who belongs to the club. It prevents invalid states such as having two coaches. It owns the staff member list, and it protects the integrity of the club. All the business rules are available in the domain, and they are not scattered around the application. Before we finish our club management bounded context, we also need to complete the staff contract class. Here in this class, now we can add the reference of the club ID. That will tell us which club is hiring this staff member under this contract. In this part of the video, we will implement our next bounded context, that is the squad management context. This context is all about players. We will implement two aggregate rules, player and the player contract, along with some enums that will represent some characteristics of the players. We will also implement a value object, player stats, that will encapsulate the stats related to players. Let's start the implementation of the squad management context. we have already created a players folder in which we will implement all the classes related to squad management. The first thing I'm going to implement in this folder is a player position enum. This enum will represent the position on which the player plays on the field. This enum is going to be public. And inside this enum, we will define different positions such as goalkeeper, defender, midfielder. This enum will now ensure that the player can only have one of these four valid positions. No invalid and misspelled values are now possible. The next enum we need to create in the squad management context is a player status. This enum will tell us the current career state of the player. For example, football player can be actively playing, temporarily injured, or permanently retired. So let's define some values. For example, active, injured, or retired. This enum will make it very easy for us to control some business rules related to players. For example, preventing the retired players to sign the contract. The next thing we need to create in our squad management context is a player stats value object. This value object will represent the player's performance, such as how many matches they played, how many goals they scored, and how many assists they made. Let's add this value object in our players aggregate folder. The name of the value object is player stats. Once again, I'm going to add the read-only, bracket, and the struct keywords with this value object. And this value object will also implement the iValue object interface. Internally, this value object will encapsulate three types of stats. For example, appearances, goals, and assists. We are now ready to create the first aggregate root of the squad management context. This aggregate root will be a player contract and it will represent the contract between the player and the club. The reason I have decided to create the player contract as an aggregate root because it will manage all the business rules related to contract lifecycle. Let's add a new class in the players folder and name it player contract. This class will also inherit the base entity class and it will also implement the iAggregate root interface. The first property will be an ID property and it will be a strongly typed player contract ID. Let's quickly add this player contract ID as a strongly typed ID in the players folder. This strongly typed ID will be similar to the strongly typed IDs we created earlier. It will encapsulate the quit value and it will implement the iValue object. Let's quickly add another strongly typed ID in the players folder and name it player ID. This value object will be used to represent the strongly typed ID of the players. Let's make it read-only, bracket, and struct. Let's jump back to the player contract aggregate to add some more properties. The next property I'm going to add is the player ID. This property will tell us which player is signing this contract. Next, we need the club ID property. This property will represent a club who is hiring this player under this contract. Next, we need a property to specify for how long this contract will remain active. For this property, we can use the date range value object we created earlier. Next, we need a property to specify the salary of the player. We can use the money value object to represent the salary. Next, we need a property that will specify on what position the player will play under this contract. And this is where we can use the player position enum we created earlier. Next, we need a property that will represent the shirt number the player will wear. Final property we need is to specify the status of this contract. For this purpose, we can use the contract status enum we created earlier. Just like other entities and aggregate roots we created earlier, we also need private constructors in this aggregate. First, I'm going to implement the empty private constructor for the entity framework. The second private constructor will be parameterized. This constructor will accept some parameter to initialize the player contract object. For example, I can pass the parameters such as player ID, club ID, period, salary, position, shirt number, and status. Inside the constructor, I will first initialize the player contract ID. Here, I can pass the new GUID ID. Next, I'm going to initialize all the properties one by one, such as player ID, club ID, period, salary, position, shirt number, status. Next, we need to implement the public static factory method to create the player contract objects from outside. Parameters of that method will be similar to this player contract constructor. Let's copy this private constructor and paste it below. I need to make sure that this method is public static and this method name is create. I can remove all the implementation code of this method. Here we can create and return a new player contract object. And we can pass all the parameters to this constructor. Once we have the method to create the player contract, we are now ready to add some business logic in this aggregate rule. Let's say you want to know if this player contract is active or not. The business rule says that the player contract will be active if two conditions are met. The first condition is that its status is active. And the second condition is that today's date must be within the range of the contract period. If you remember, we have already implemented the similar logic in our staff contract class. So let's open the staff contract class. And here is the property that you need in the player contract object. So let's copy this property from here and paste that property inside the player contract object. Now this property will return the value true only if the contract is active based on these two conditions we specified here. Next thing I'm going to implement is a method named terminate. This method will be used to terminate the player contract. Implementation of this method is very straightforward. We just need to change the status of the contract to terminate it. But let's say you want to enforce a business rule here, and the business rule is that the contract can only be terminated if it is active. You can enforce this business rule very easily using the status property. Here you can check if the contract status is not active. You can throw a domain exception with a message such as only active contract can be terminated. The final and the most important aggregate root of the squad management context is a player aggregate root. So let's create a new class in the players folder and name it player. This class will also inherit from the base entity and it will also implement the iAggregate root. Let's quickly add some properties in this aggregate root. First property will be a strongly typed player ID identity property. Next, I need a property to specify the player name. Next, I'm going to create a property that will specify the player date of birth. Next, I need a property that will specify the nationality of the player. Next property will be a status property, and here we can use the player status enum we created earlier. Next, we need a property that will specify the stats of the player. For this purpose, we have already created a player stats value object. Finally, we need a property that will represent the collection of player contracts. Let's quickly implement our standard private constructors for this entity. The first constructor will be empty constructor and the second constructor will accept some parameters such as name, birth date, nationality, and player status. Inside the constructor, let's first initialize the ID property with the new GUID ID. Next, we can initialize the other properties such as name, nationality, birth date, and status. And we can copy and paste this same constructor below and convert this into a public static factory method. Just like our previous examples, this method will also return a new player object. Next thing I'm going to implement in this player aggregate root is a method named sign contract. This method will accept a parameter of type player contract. And inside this method, I need to add this new contract in my existing contracts collection. Now, once again, we need to think about some business rules we can enforce here. For example, there could be a business rule that the player cannot sign a contract with two clubs at the same time. In other words, if the player already have an active contract with some club, he cannot sign another contract. Let's implement this business rule inside this sign contract method. Before signing a new contract, I need to check if the player already have one active contract available. I can check this easily using the any method. If this condition will become true and player already have one active contract available, I can simply throw a new domain exception. And here I can specify that the player already has an active contract. Now this player aggregate will make sure that the player entity is always in a consistent state, and we cannot have any player in the system with two active contracts. Let's quickly recap what we have learned in this squad management context. Players have positions, stats, and career statuses. Player contracts keep track of the club's player salaries and time periods. And finally, we have the player aggregate that not only stores some information about the player, but also enforce business rules such as one active contract at a time. This is how a realistic football league application domain model will look like if you will implement it using a domain-driven design. The last bounded context we need to implement is the transfer management context. This context is all about the transfers of the players. The domain model of the transfer management context includes two enums, one value object, and one aggregate root. The first enum I'm going to create in the transfer folders is called the transfer type. This enum will store two values, permanent and loan. And these values will tell us whether the transfer is permanent or just a loan. The second enum I'm going to create is a transfer status. This enum will describe the life cycle of the transfer, such as proposed, approved, rejected, or completed. Transfer usually starts as proposed, and later on it can be approved or rejected. And finally, it ends as completed. In the real world, you can only buy and sell players during the transfer window. To represent this concept using the domain-driven design, we need to implement a value object transfer window. This value object will represent the time period when the transfers are allowed. Let's add this transfer window value object in the transfer folder. This value object will be read-only, racket, and struct. Just like other value objects, it will also implement the iValue object interface. I'm going to create two properties in this value object. These properties will specify the start date and the end date of the transfer window. Let's create the first property, opens at. This property will tell us when the transfer window is open. Next property will be closes at, and this property will specify when the transfer window will close. We can also implement a useful method isOpen in this value object. This method can accept a datetime parameter, and it can check whether the given date is inside the allowed transfer window. Let's implement this method. Before we implement our main transfer aggregate rule, let's just quickly create a transfer ID as a strongly type ID. This ID will be similar to the other strongly type IDs we already implemented. Finally, we are ready to implement the heart of the transfers, and that is the transfer aggregate rule. So let's create a new class in this folder and name it transfer. This class will inherit the base entity and it will implement iAggregate root. I am now going to define some properties related to transfer. The first property will be a strongly typed transfer ID. Next property will be a strongly typed player ID. This property will specify the player who is being transferred. Next, we need a strongly typed from club ID property, and this property will specify from which club the player is transferred. Similarly, we also need a strongly typed toClub ID property. This property will represent the club to which the player is transferred. Next, we need a property that will specify the transfer fee. Next, we need a transfer date property. Finally, we need a property that will specify the current transfer status. These properties can help us to implement all the business rules for moving a player from one club to another club. Let's quickly implement our standard private constructors. The first constructor will be an empty constructor. As you might already know, the second constructor will be a parameterized constructor. First parameter will be a player ID. Second parameter will be from club. Third parameter will be to club. Fourth parameter will be fee. Next, we need a transfer date parameter. And finally, we need a status parameter. Let's quickly initialize these properties, including the ID property. As we have done this before, we can copy this private constructor and convert this into a public static factory method below. This public method will be similar to the other method we implemented earlier, and internally it will return a new transfer object. I hope now you have an idea how to implement the domain model of a real-world business application using the domain-driven design. If this video helped you to understand the domain-driven design better, please hit the like button. And don't forget to subscribe to my channel for more domain-driven design and software architecture videos. Until next time, stay awesome.